Hello, in this video we will discuss about C++ operator. In the previous video we talk about arithmetic operator and the relational operators. In this video we will talk about the logical operators, bitwise operators and conditional operators, and the last one is assignment operator. Let's start with logical operator. You can see here this is the symbol or the sign of logical operators. This is logical AND, this is logical OR, and this one is the logical NOT. In +2 you studied about gates, that are the AND gate, OR gate, NOT gate. For the AND gate, you can see here this is the truth table for the AND gate. For this, if both values are false, then the output would be false. If both are true, then the output would be true. If one value is true and one is false, then output would be false. And it is true only for these. If both the values of A and B is true, then the result is true. So same we are doing here for the programming. You can see here in the logical AND, it evaluates to true. If both operands are true, then it would be true. You can see here with an example, we have the value of x is 5, the original value of x is 5, and the original value of y is 2. For the case 1, you can see here in the case 1 we have the value of x is 3, and we use this operator here, y is equal to 6. Check the value, is x is 5 is equal to 3. No, this is false. Y is 2 is equal to 6. This is also false. That is, we have two conditions that are false. One false, two false. Check in the truth table. If you have two false, then the output would be false. That's here. For the case 2, you can check here, x is 5 and 5 is not equal to 3, that is false. And here 2 is equal to 2, the condition is true. We have one false and one true. Check in the truth table, we have one false and one true, then the result would be false. For the third case, you can see here the value of x is 5 and here is also 5, value matched, condition is true, and value of y is 2 and it is not equal to 0, therefore this condition is false. Therefore we have one true, one false. Check the truth table, we have one true, one false, then the final output would be false. This is the question for you. For the case 4, you will tell me what is the final output of this one. Next one is logical OR. For the logical gate, if only one condition is true, then the final output would be true. Here you can see we have one false, one true, then the final output would be true. If we have two trues, then the final output would be true. If both are false, then the final output would be false. Let's see this with an example. We represent false value with 0 here and the true value with 1. In this case, we have again the value of x is 5 and the value of y is 2. For the case 1, check the value, is 5 is less than 3, condition is false, or y, that is 2 is equal to 2 is equal to 6. Both these conditions are false because 5 is not less than 3 and 2 is not equal to 6. Therefore, the output is false. Next case is x is equal to 3, that is 5 is equal to 3, condition is false, or y 2 is equal to 2. Here the condition is true. We have one false, one true. Check the truth table, one false and one true, then the output would be true, because if you have one condition is true, then the output would be true for the logical OR. For the case 3, you will check the values and you will tell me the output of this. In the case 4, we have the value of x 5 and it is equal to 5, condition is true. We have value of y is 2 and it is equal to true. Here we have two true values. You can see in the truth table, if you have two true values, then the output would be true. Done. This is the logical AND. Here if you have true value is true, then the output would be false. If you got condition false, then the output would be true. Check this here in the case 1, check whether x that is 5 is greater than 3, that is true. yes, 5 is greater than 3. Condition is true, then the output would be false. Check case 2, is x equal to 3? No. Here condition is false, then the output would be true. Done. Next operator is bitwise operator. Here these are the symbols of the bitwise operator. This is called bitwise AND, this is bitwise OR, this is bitwise exclusive, or you can say XOR. This is bitwise ones complement, and this is shift left, and this is shift right. These are the bitwise operators. Let's see with an example. As you can see, the AND gate, this is the OR gate, and this is the XOR gate. You know, in the AND gate, if you have both the values are true, then the output would be true. If one of them is false, then output would be false. You can check the values for the AND gate. Both are false. If 0 represents false and 1 represents true, these both are false, then output would be 0. This is also 1 is false, then output would be false. 1 is again false, output would be false. Both the values are true, then the output would be 1. For the OR gate, we need only one true value, and here you can see we have one true value, and both are true values. Then the result is 3 1 and 1 0. For the XOR gate, how you will check? You will check if you have 2 bits. These are bits different. If you have 2 different bits, that is, here you can see you have 0 and 1. These 2 bits are different, then the result would be 1, that is a true value. If you have the same bits, then the result would be 0, that is the false value. This is about the bitwise operators. Now the last one is conditional operator. That is the symbol of the conditional operator, and this is similar to if-else statement. If the condition is true, then your statement will be executed, else the else part of the statement will be executed. Let's see with an example. Here you can see the variable, we have the expression 1, then this is the condition, and this is the expression 2, expression 3. Here you can see the conditional operator is applied in between these expressions, here and here. This is the symbol of this operator. Now let's see this with an example. Here you can see this is the expression 1, this is expression 2, and this is expression 3. If A is greater than B, check. This is the conditional. We applied here this operator. We are checking this condition. If A is greater than B, then C is equal to A, else C is equal to B. Again I'm saying, if A is greater than B, then A is equal to B, else A is equal to Let's see this with an example. As you can see here, this operator is like if-else statement. Check this. If A is greater than B, then C is equal to A, else C is equal to B. Done. Here we have the conditional operator applied here on this expression 1. We apply this operator. You will check this. If A is greater than B, then C would be equal to A, else it would be equal to B. So in this video we talk about this operator. In the conditional operator you will check the expressions and the conditions, and it is similar to if-else statement. And in the bitwise operator, you can see here we have bitwise AND, bitwise OR, and the XOR gate. For the OR gate, if one value is true, then output would be true. If both are false, then output would be false. If in the AND gate, if only 2 values are true, then the output would be true, and for the rest that would be false. And in the XOR gate, if the 2 bits are different, then the output would be true, else it is false. And in case of this logical AND, logical OR, we will check the conditions. It is similar to AND or NOT gate. Notes are given below in the description box. If you have any question, then you can ask me. Thanks for watching this video.